Have you ever wondered how a small delivery robot could navigate the chaos of a city sidewalk? It's a much harder problem than you might think. Welcome to Summarize Science, where we break down the latest research. Today, we're looking at a new AI called UrbanVLA, which is designed to solve this very challenge. Current navigation systems for robots often need super detailed, expensive maps, or they rely on consumer apps like Google Maps, which just aren't precise enough for a robot's movements. A robot needs to understand not just the route, but also how to deal with pedestrians, curbs, and constantly changing environments. UrbanVLA acts like a smart co-pilot for the robot. It takes general route instructions, like go straight and turn right, and combines that with what its cameras are seeing in real time. As you can see in this diagram, it fuses language instructions and visual information to decide on the exact path to take. This allows it to navigate long distances by intelligently correcting for the noisy and sometimes inaccurate directions it's given. So, how do you teach an AI to be such a good navigator? The researchers used a clever two-stage training process. First, the AI learns the basics by watching thousands of hours of navigation data, both from realistic simulations and from videos of people moving around cities. This initial phase is called supervised fine-tuning. But to make it really robust and safe, they use a second stage called reinforcement fine-tuning. Here, the model is refined using a mix of simulation data and data from humans actually steering a robot in the real world. This teaches the AI how to handle tricky, real-world situations and prioritize safety above all else. And the results are seriously impressive. In simulated tests, UrbanVLA outperformed all previous methods by a massive margin, in some cases by over 55%. What's even more amazing is that it achieved this using only standard RGB cameras. It performed even better than other models that had access to more advanced LiDAR sensors. It also scored very high on social compliance, meaning it's good at politely navigating around people without getting in their way. Of course, simulations are one thing, but the real world is the ultimate test. The team deployed UrbanVLA on a four-legged robot and set it loose in various complex urban environments. These images show it successfully navigating overpasses, busy street corners, and crowded pedestrian areas. It managed to complete long-horizon tasks, traveling over 500 meters while adapting to dynamic obstacles and different lighting conditions. This demonstrates its incredible ability to generalize from its training to completely new and unpredictable scenarios. So to recap, the researchers behind UrbanVLA have created a powerful new AI for robot navigation that smartly combines high-level route guidance with what the robot actually sees. It's trained using a robust simulation-to-real-world pipeline that emphasizes safety and adaptability. This is a huge step towards making autonomous micromobility a reality. Imagine a future where fleets of these robots are safely delivering packages, groceries, or even acting as guide robots for those with mobility challenges. The technology in UrbanVLA brings that future one giant step closer.